Imagine looking up at the night sky. You see stars, you see the moon, maybe you see a planet, a bright wanderer. But there is something else up there, something we put there, something that now poses a growing danger. This is the story of space debris. It is a story about our triumphs in exploration. It is also a story about the mess we have left behind. In early 2025, a stark reminder flashed across news screens. The International Space Station had to perform an emergency maneuver. A piece of an old satellite no bigger than your hand was hurtling towards it. A collision was narrowly avoided. This was not the first time, and it certainly will not be the last unless we act. This silent threat orbits our planet. It travels at incredible speeds. Think about a bullet. Now imagine something many times faster. Even a tiny fleck of paint can cause significant damage at these velocities. These are human-made objects, they are broken satellites, they are spent rocket stages. They are fragments from past collisions. Each piece, large or small, adds to an invisible cloud of danger. This cloud is growing every year, making our near-Earth space a more hazardous place to be. The incident with the space station was a close call. It highlighted a problem that scientists have been warning about for decades. We have been launching objects into space since the late 1950s. For a long time, we did not think much about what happened to them when they stopped working. We treated space like an infinite dumping ground. But space, especially the space close to Earth, is not infinite. It is a precious resource. So, what exactly is this space debris we are talking about? Think of it as cosmic litter. It is any piece of machinery or debris left by humans in space. It can be big, it can be small, it can be an entire old satellite that no longer works. It can be a large rocket body that pushed a satellite into orbit and is now just tumbling around. These are some of the largest pieces of debris. They are like abandoned cars on a celestial highway. But not all debris is large. Many pieces are quite small, yet still dangerous due to their high speeds. Imagine a tiny screw, or a fleck of paint, or a lost glove from an astronaut's spacewalk. The primary source of space debris is old satellites. When a satellite reaches the end of its useful life, or if it malfunctions, it often just stays in orbit. Sometimes these dead satellites can collide with other objects. This creates even more debris. Another major source is rocket stages. When a rocket launches a payload, it uses different stages. Once a stage has used up its fuel, it is often discarded in orbit. Just how much of this cosmic litter is actually up there? The numbers are quite staggering. Space surveillance networks around the world track the larger pieces of debris. These are objects generally larger than about 10 centimeters, or 4 inches, in diameter. Think of something the size of a softball or bigger. There are currently more than 36,500 such objects being tracked. That is a lot of big stuff. But this is only the tip of the iceberg. The real problem lies in the smaller pieces that are much harder to detect and track. These smaller pieces are far more numerous. Scientists estimate that there are around 1 million pieces of debris between 1 and 10 centimeters in size. That is roughly the size of a marble up to a softball. Each one of these is capable of causing catastrophic damage to an operational satellite or a spacecraft. And then there are the even smaller particles. Objects smaller than 1 centimeter like flecks of paint or tiny metal shards. It is estimated that there could be more than 130 million of these tiny bullets whizzing around our planet. While they might seem insignificant, their extreme velocity makes them dangerous projectiles. Section 4. Playing dodgeball at orbital speeds, the risks. The dangers posed by space debris are very real. They affect our satellites, our space missions, and even our astronauts. Imagine trying to navigate a spacecraft through a minefield. That is what operating in some parts of Earth's orbit is becoming like. The primary danger comes from the sheer speed of these objects. In low Earth orbit, objects travel at roughly 7.8 kilometers per second. That is about 28,000 kilometers per hour or 17,500 miles per hour. To put that into perspective, it is about 10 times faster than a rifle bullet. At these speeds, a collision with even a small piece of debris can have devastating consequences. Our modern world relies heavily on satellites. We use them for communication, like mobile phones and internet services. We use them for navigation, like GPS systems in our cars and phones. We use them for weather forecasting and monitoring climate change. We use them for television broadcasting and for scientific research. All these satellites are vulnerable to space debris. A collision with a piece of debris can damage a satellite's solar panels, its antennas, or its sensitive instruments. Section 5. An endangered frontier. Space as an environment. When we think about environmental protection, we usually think about Earth. We think about our forests, our oceans, and our atmosphere. But the space around Earth is also an environment. It is a unique environment that humanity is increasingly using, and just like on Earth, our activities can have negative consequences if we are not careful. Space debris is, in essence, a form of pollution. It is polluting the orbital environment. This pollution does not just pose a risk to our current space assets, it also threatens the long-term sustainability of space activities for future generations. We are, in a way, littering our own cosmic backyard. The most direct environmental impact is the physical cluttering of useful orbits. Section 6. The big cleanup, tackling the orbital mess. So what can we do about this growing problem of space debris? The good news is that we are not powerless. Scientists, engineers, and policymakers around the world are working on solutions. These solutions generally fall into two categories: mitigation and remediation. Mitigation means preventing the creation of new debris. Remediation means actively removing existing debris from orbit. Both are essential if we want to ensure the long-term safety and sustainability of space activities. It is a complex challenge, but one that we must address with urgency and innovation. Mitigation measures are focused on responsible behavior in space. International guidelines have been developed. One important set comes from the Interagency Space Debris Coordination Committee, or IADC. These guidelines encourage satellite operators to design their spacecraft to minimize the release of debris during normal operations. They also recommend that satellites be moved to less crowded graveyard orbits at the end of their operational lives, especially for those in geostationary orbit. For satellites in low Earth orbit, the guidelines suggest designing them to deorbit naturally within 25 years after their mission ends. This means they will re-enter and burn up in Earth's atmosphere. Many new satellites are now designed with these principles in mind. However, mitigation alone is not enough to solve the problem. There is already too much debris in orbit, especially large, non-functional objects like old rocket bodies and defunct satellites. Section 7. Our future above. A call for clear skies. We stand at a cosmic crossroads. Our ability to explore, to communicate, to understand our planet, and to venture out into the solar system depends on safe access to space. Yet the very frontier we seek to explore is becoming increasingly hazardous due to the clutter of our own making. The challenge of space debris is not just a technical problem for engineers, it is a reflection of our responsibility as a species. Just as we have learned, sometimes the hard way, to care for our terrestrial environment, we must now extend that stewardship to the heavens above. The future of our activities in orbit, and perhaps even our future as a spacefaring civilization, hangs in the balance. The path forward requires a concerted effort on multiple fronts. We need continued investment in research and development of debris mitigation and removal technologies. We need innovative solutions that are both effective and affordable. This means supporting our scientists and engineers who are working on these challenging problems. It means encouraging new ideas and new approaches. Governments, space agencies, and private companies all have a role to play in fostering this innovation. The cost of inaction in the long run will far outweigh the cost of investing in solutions now. We must think not just about the next mission, but about the next generation of explorers and space users. Public awareness and understanding are also crucial. Many people are simply unaware of the extent of the space debris problem or its potential consequences.